You know the great red spot, that iconic storm on Jupiter, larger than Earth. Raging for centuries. Beautiful, mesmerizing, completely irrelevant. Because while we've been obsessing over Jupiter's weather, we missed the real story happening beneath it. Those clouds we love to photograph? They're only 50 kilometers deep, a rind, a skin, a whisper-thin veil covering something so strange that it rewrites the rules of planetary science. Beneath the red spot, beneath all those swirling bands of ammonia and water vapor, lies an ocean 2,000 times deeper than Earth's Mariana Trench. An ocean that rains mud made of ammonia ice. An ocean that has waves of heat instead of water. An ocean that eventually transitions into a metallic fluid that generates magnetic storms powerful enough to strip satellites of their electronics. We've been watching Jupiter's surface for 400 years, like tourists admiring wallpaper, never thinking to ask, what's behind it? The answer is terrifying and beautiful in equal measure. And I need you to understand why this matters. Not just as a curiosity, not just as another space fact to file away in your mind alongside the number of moons Saturn has or how hot the sun burns. This matters because everything you learned about Jupiter, everything you were tested on in school, everything you saw in documentaries, everything scientists confidently declared for decades was fundamentally wrong. And the wrongness of it reveals something profound about how we understand reality itself. You see, we've been taught to think of planets as simple objects, rock or gas, solid or empty, dead or alive, clean categories that make the solar system feel manageable, understandable, safe. Jupiter was the gas giant, the big puffy ball of hydrogen and helium, swirling storms on the outside, maybe a small rocky core buried somewhere deep inside. That's what the textbook said. That's what teachers taught. That's what humanity believed for generations. But in 2016, when NASA's Juno spacecraft arrived at Jupiter after a 5-year journey and began mapping the planet's gravitational field with unprecedented precision, everything changed. The data that came back didn't just surprise scientists, it shocked them into silence. Because what Juno revealed was that Jupiter isn't a gas giant at all, it's a liquid planet, an ocean world. And not just any ocean, an ocean of liquid hydrogen, so deep it would swallow Earth's oceans 2,000 times over. An ocean that, at its deepest points, transforms into something even stranger, metallic hydrogen. A state of matter that has never been created in a laboratory, that exists nowhere else in our solar system, that conducts electricity like copper while flowing like mercury. We've been staring at Jupiter for 4 centuries, and we were looking at the wrong thing entirely. Now, I want you to sit with that for a moment. 400 years, Galileo Galilei pointed his primitive telescope at Jupiter in 1610 and saw 4 moons orbiting it, a discovery that helped prove the Earth wasn't the center of the universe. Since then, we've sent spacecraft, we've built better telescopes, we've studied Jupiter with every instrument we could devise. And until less than a decade ago, we fundamentally misunderstood what it was made of. If we can be that wrong about the largest planet in our solar system, an object so massive it contains more than twice the mass of all the other planets combined, an object visible to the naked eye, an object we've photographed and measured and mapped, then what else are we wrong about? What else are we mistaking surfaces for substance? What else are we calling gas when it's actually liquid metal? This video is going to take you on a journey into Jupiter's interior. We're going to descend through those famous clouds, past the great red spot, into the ammonia rain and the lightning storms, down into the ocean of liquid hydrogen, and finally to the metallic core that shouldn't exist according to our models of planetary formation. But more than that, we're going to explore what it means to be wrong, what it means to realize that complexity doesn't fit into clean categories, what it means to discover that the universe is stranger, far stranger than we've been told. Because here's the truth that Jupiter reveals. You don't need to make sense. The universe doesn't owe you simplicity. Reality is allowed to be messy, contradictory, impossible to fully explain. And so are you. Let me start by taking you back to a moment that changed everything we thought we knew about Jupiter. It was July 1000, 995, and something extraordinary was about to happen, a cosmic event so rare, so perfectly timed, that it seems almost orchestrated by fate itself. A comet called Shoemaker-Levy 9 had been wandering through our solar system for millions of years, following its lonely orbit through the darkness. But comets don't last forever. Eventually, their paths intersect with something larger, something with enough gravity to alter their destiny. For Shoemaker-Levy 9, that something was Jupiter. When the comet entered Jupiter's gravitational field, the planet didn't capture it gently. Jupiter's gravity is immense, 2.5 times stronger than Earth's, and it grabbed that comet and tore it apart, literally ripped it into pieces. By the time astronomers discovered Shoemaker-Levy 9, it had already been fractured into 21 separate fragments, each one a mountain of ice and rock, each one hurtling toward Jupiter at 216,000 kilometers per hour. Scientists calculated the trajectory. They knew the impacts were coming. They prepared every telescope, every instrument, every camera. This was going to be spectacular, the largest collision ever witnessed in our solar system, fragments the size of cities slamming into the solar system's largest planet with the combined energy of millions of atomic bombs. But there was a problem, a heartbreaking problem. The fragments were going to strike Jupiter's far side, the hemisphere facing away from Earth. We would miss it, all of it. We'd spend months anticipating this cosmic spectacle, and when it finally happened, we'd be staring at the wrong side of the planet, blind to the impacts, able only to imagine the explosions happening beyond the curve of Jupiter's horizon. Except we weren't going to miss it. Because at that exact moment, in one of those coincidences, that makes you wonder if the universe has a sense of drama. NASA had a spacecraft arriving at Jupiter. It was called Galileo, named after the astronomer who first studied Jupiter through a telescope. Galileo had been launched in 1989 on a 6-year journey to investigate Jupiter and its moons. It was scheduled to arrive in December 1995, just months after the comet impacts. But its approach trajectory gave it a perfect view of something humanity had never witnessed before, a comet bombardment of another planet. For 6 days in July 1995, fragment after fragment slammed into Jupiter. Each impact was cataclysmic. The largest piece, about 2 kilometers across, hit with a force of 300 million atomic bombs. Think about that, 300 million. The explosion was so violent, it created a fireball that rose thousands of kilometers above Jupiter's clouds. The impact site glowed brighter than the planet's surface, visible even through the Hubble Space Telescope orbiting Earth. As Jupiter rotated, those impact sites came into view from Earth, and what we saw were massive black scars in the clouds, wounds larger than our entire planet, dark bruises that persisted for months. The impact had punched through Jupiter's atmosphere, excavating material from deep inside, throwing it into space like a cosmic excavation. And this is where the story gets interesting. Because Galileo wasn't just watching from a distance, it was flying through Jupiter's neighborhood, and its instruments were designed to analyze the composition of anything they encountered. When those comet fragments punched through Jupiter's clouds and ejected material from deep inside the planet, Galileo flew through the debris field and tasted it. Water, vast, unexpected quantities of water vapor. Now, scientists knew Jupiter had water, but finding this much water ejected from these depths was strange. It didn't match the models. According to our understanding of how Jupiter formed, water should be scarce in the upper layers it should have sunk, pulled down by gravity into the deeper interior. But here it was, abundant, mixed with ammonia and other compounds, revealing an atmospheric composition far more complex than we'd imagined. The finding was troubling enough that it sparked an entirely new mission. Scientists decided they needed another spacecraft, one specifically designed to probe Jupiter's deeper secrets, to map its interior, to answer once and for all what this giant planet was actually made of. That mission was named Juno, and it would take another 21 years from conception to arrival before we'd get our answers. Juno launched in 2011, 5 years of travel time, 5 years of waiting, the spacecraft hibernating through the darkness, waking periodically to send a signal back to Earth. I'm still here. I'm still on course. 5 years of anticipation building in the scientific community because they hoped that Juno would finally reveal what was beneath those clouds. The spacecraft arrived at Jupiter in July 2016, and it carried instruments unlike anything we'd sent before. Not cameras designed to take pretty pictures, though it had those too, but instruments designed to measure gravity, to detect the tiniest variations in Jupiter's gravitational pull as Juno orbited overhead, variations that would reveal how mass was distributed inside the planet, because gravity doesn't lie. You can't hide mass. If there's a dense core, gravity will reveal it. If the interior is layered, gravity will show the boundaries. If something strange is happening deep inside Jupiter, gravity will betray its secrets. And that's exactly what happened. The data Juno sent back rewrote planetary science. Because what it showed was that Jupiter's interior is nothing like we imagined. Not even close. Let me take you on a journey now. Let me describe what it would be like to descend into Jupiter layer by layer if you could somehow survive the experience. Because understanding Jupiter isn't just about knowing facts, it's about feeling the visceral strangeness of a world that operates by rules we've never encountered. Imagine you're falling toward Jupiter. From a distance, it's beautiful, those bands of color, rust orange and cream white, swirling in patterns that look like brushstrokes from some cosmic artist. The great red spot dominates the southern hemisphere, a storm larger than Earth that's been raging for at least 350 years, possibly much longer. It's the most famous weather system in the solar system, and it's stunning. You're falling faster now, accelerating toward those clouds. The temperature's dropping. At the cloud tops, it's negative 145 degrees Celsius. Cold enough to freeze carbon dioxide solid. Cold enough that if you were breathing, your breath would crystallize instantly into snow. You hit the first layer of clouds, ammonia, ice crystals, swirling in the jet streams that circle the planet. These aren't gentle clouds like on Earth. They're moving at hundreds of kilometers per hour, driven by winds that make Earth's hurricanes look calm. You're buffeted, thrown sideways, caught in a current that could carry you around the entire planet in a matter of hours. And then the lightning starts. Jupiter's lightning is different from Earth's. It's 1,000 times more powerful. Each bolt carries more energy than the largest thunderstorms humanity has ever recorded. And it's everywhere, flashing constantly, illuminating the clouds from within, creating a strobe light effect that would be beautiful if it weren't so terrifying. The flashes reveal the structure of the clouds around you, towering formations that rise and fall, convection cells the size of continents, all churning, all moving, all electrified. You fall deeper. The ammonia clouds give way to water clouds, and here things get even stranger. On Earth, water and ammonia don't mix well. Ammonia is toxic, caustic, dangerous. But here, in Jupiter's upper atmosphere, they combine. The ammonia acts like antifreeze, lowering the freezing point of water, allowing liquid droplets to exist even in the extreme cold. These droplets collide with ice crystals, generating static electricity, feeding the lightning storms that rage continuously across the planet's surface. The temperature is rising now. You've descended maybe 100 kilometers below the visible cloud tops, and the pressure is increasing. You can feel it, not that you'd survive to feel it, but hypothetically, the pressure squeezing in from all sides, compressing the gas around you, making it denser, thicker, harder to move through, and then something shifts. The distinction between gas and liquid begins to blur. You're now about 1,000 kilometers deep, and the hydrogen that makes up most of Jupiter's atmosphere is no longer behaving like a gas. The pressure has become so intense that the molecules are packed together tightly, forced into proximity, unable to spread out the way gases normally do. It's becoming a liquid. Not because it's cold, it's actually getting hotter as you descend, but because the pressure is so immense that it's forcing a phase change. This is Jupiter's ocean, not water. Hydrogen. Liquid hydrogen, existing at temperatures over 1,000 degrees Celsius, kept liquid not by cold, but by pressure. Try to imagine that. An ocean where the temperature is hot enough to melt most metals, But the pressure is so high that hydrogen, the lightest element in the universe, the element that floats away into space on Earth, is compressed into a liquid state. An ocean 20,000 kilometers deep, 20,000 kilometers. The circumference of Earth is only 40,000 kilometers. This ocean could contain our entire planet and still have room to spare. You continue falling. The ocean isn't uniform, it's churning, convecting, with currents that flow vertically as well as horizontally. Hot hydrogen rises from below, cools slightly as it approaches the upper layers, then sinks again. These convection cells are enormous, hundreds or thousands of kilometers across, moving slowly, ponderously, like the mantle beneath Earth's crust, but made of liquid hydrogen instead of molten rock. The deeper you go, the hotter it gets. 2,000 degrees, 5,000 degrees, 10,000 degrees. Heat that isn't coming from the sun. The sun's warmth is irrelevant at this depth, 5.5 light hours away, but from Jupiter itself. The planet is generating heat through gravitational compression. Every atom in Jupiter is being pulled toward the center by gravity. And that compression generates energy, creates warmth, turns the interior into a furnace, and then, at a depth of about 40,000 kilometers, something impossible happens. The hydrogen changes not into a solid, it's far too hot for that. It changes into metal, metallic hydrogen. Let me explain what this means, because it's genuinely one of the strangest phenomena in the known universe. On Earth, metals are solid. They're hard, shiny, conductive. They're things like iron and copper and gold elements with specific properties that we can hold in our hands, shape with tools, use to build things. Hydrogen is the opposite. It's a gas, the lightest element, so diffuse that it floats away into space if it's not contained. Calling hydrogen a metal sounds like a contradiction. But under extreme pressure, the kind of pressure that exists deep inside Jupiter millions of times, Earth's atmospheric pressure, hydrogen's behavior changes fundamentally. The atoms are squeezed so tightly that the electrons, which normally orbit the nucleus in neat little shells, are stripped away. They're liberated, freed to move through the material like a fluid. And when electrons can move freely, you get electrical conductivity, you get metallic behavior. So metallic hydrogen is still liquid. It flows, it churns, it moves like water or oil or mercury, but it conducts electricity like copper wire. It's a liquid metal, a substance that has never been created in a laboratory despite decades of attempts. A material that exists only in the crushing depths of giant planets. And this metallic hydrogen ocean makes up most of Jupiter's mass. It's not a small layer, not a curiosity buried at the core. It's 40,000 kilometers deep, extending from the middle of the planet almost halfway to the surface. It's the dominant component of Jupiter's interior, and we only discovered it existed in the last few years. As this metallic hydrogen churns, driven by the same convection that moves the liquid hydrogen ocean above it, it generates electric currents, and electric currents generate magnetic fields. This is how Jupiter's magnetic field is created. Vast rivers of liquid metal flowing through the planet's interior, conducting electricity, creating a magnetic field so powerful it extends millions of kilometers into space. How powerful? Jupiter's magnetic field is 20,000 times stronger than Earth's. It traps radiation from the sun and from Jupiter's own volcanic moon Io, concentrating it into belts that would kill an unprotected astronaut in minutes. It creates auroras at Jupiter's poles that are 1,000 times brighter than Earth's northern lights. It's a force that dominates the entire Jovian system, affecting the moons, deflecting solar wind, creating a bubble of magnetic influence that extends almost to Saturn's orbit. And all of this immense, invisible power is generated by liquid metal flowing in the dark 40,000 kilometers beneath those pretty clouds we've been photographing for centuries. You're still falling, past the metallic hydrogen, deeper still toward the core. And this is where things get truly mysterious, because what we found at Jupiter's center defies everything we thought we knew about planetary formation. We expected a core, a dense, compact ball of rock and iron, maybe the size of Earth, maybe 10 times Earth's mass. This made perfect sense. According to our models, Jupiter formed when a rocky planetary embryo, a protoplanet, grew large enough that its gravity started capturing gas from the disk of material swirling around the young sun. The rock and metal sank to the center, compressed by their own weight into a tight sphere, while the hydrogen and helium piled on top, layer after layer, until you got the massive planet we see today. Neat, logical, consistent with how we think planets form. Except Juno's gravity measurements revealed something different. The core isn't compact, it's diffuse, spread out, blurred. Instead of a clean boundary liquid metal here, solid core there, what we're seeing is a gradual transition. A region where metallic hydrogen blends with rock and iron, where liquid mixes with solid, where the distinction between core and mantle becomes meaningless. This diffuse core region extends across half of Jupiter's radius. It's not a small anomaly, it's a fundamental feature of the planet's structure. And we don't know how it got this way. The leading theory is collision. Early in the solar system's history, maybe 4 billion years ago, maybe earlier, there might have been another planet, a rocky world 10 times the mass of Earth, that slammed into Jupiter. The impact would have been catastrophic. It would have shattered both the impactor and Jupiter's original core, distributing rocky material throughout the interior, mixing it with the metallic hydrogen, creating this strange, diffuse structure we see today. Computer simulations can reproduce this. Scientists have run the numbers, modeled the collision, watched how the cores merge and blend in the extreme heat and pressure of Jupiter's interior. And yes, the simulations create a diffuse core, but here's the problem. In every simulation, the diffuse core eventually resolidifies. Gravity pulls the heavy elements back together. The rock and iron sink toward the center, separating from the lighter metallic hydrogen, settling into a compact sphere. It takes time, millions of years, but it happens. Jupiter is 4.5 billion years old, more than enough time for the core to resolidify, and it hasn't. So either something is preventing the core from settling, some process we don't understand, some ongoing mixing or convection that keeps the heavy elements dispersed, or our models of planetary interiors are fundamentally wrong. We don't know which. And that uncertainty, that gap in our understanding, is humbling, because this is Jupiter, the largest planet in the solar system, the most studied giant planet. An object we've been observing for 4 centuries, that we've sent multiple spacecraft to investigate, that we've mapped and measured and photographed in exquisite detail, and we still can't explain its core. Now, let me pull back from the science for a moment and talk about what this means. Not just for planetary science, but for how we understand knowledge itself. For decades, for most of human history, really we taught that Jupiter was a gas giant. Every textbook said it. Every documentary showed it. Every educator explained it. Jupiter is made of gas, mostly hydrogen and helium, with maybe a small rocky core at the center. This wasn't a fringe theory. This wasn't speculation. This was consensus. This was what we told children when they asked about the planets. This was what appeared on tests, what you had to memorize to pass your astronomy class, what scientists accepted as foundational truth. And it was wrong. Not a little wrong. Not we got some details backward wrong. Fundamentally, structurally wrong. Jupiter isn't made of gas. The gas, those clouds we've been obsessing over, represents less than 1% of the planet's mass. The other 99% is liquid hydrogen, metallic hydrogen, and a diffuse core of rock and metal that doesn't behave the way cores are supposed to behave. How did this happen? How did we get it so wrong for so long? The answer is simpler than you might think. We could only study what we could see. From Earth, even with the best telescopes, we could only observe Jupiter's clouds, the swirling bands, the great red spot, the zones and belts of different colors. That's all we had access to for centuries. And from those observations, we extrapolated. We assumed that what we saw on the surface extended downward. More clouds, then maybe clear gas, then denser gas, all the way to a hypothetical core. It was a reasonable assumption. It made sense given the available evidence, But it was wrong because our evidence was incomplete. We were studying wallpaper and assuming we understood the entire house. It wasn't until we could send spacecraft equipped with gravity-sensing instruments that could detect tiny variations in mass distribution, that we could finally see beneath the clouds. And what those instruments revealed was a planet that operates by rules we'd never considered. This is a profound lesson about the nature of knowledge. We think we know things because we can see them, because we can measure them, because we can categorize them into neat boxes. Rock or gas, solid or liquid, simple or complex. But visibility isn't understanding. Observation isn't explanation. And sometimes, often, the most important truths are hidden, operating beneath the surface, invisible to our best instruments until we develop better ones. Jupiter spent 4.5 billion years being a liquid planet with a metallic ocean and a diffuse core. It didn't change when Juno arrived. It was always this way. We just couldn't see it. Our ignorance didn't alter reality. It only altered our understanding. And here's what strikes me about this. If we were that wrong about Jupiter, an object we can see with our naked eyes, that we've studied obsessively, that dominates our solar system, how much else are we wrong about? What are we mistaking for gas when it's actually liquid metal? What are we assuming is simple when it's actually layered and strange? What wallpaper are we studying while completely missing the structure behind it? I'm not asking these questions to create doubt or cynicism. I'm asking them to cultivate humility, to remind us that reality is under no obligation to conform to our models, our assumptions, our tidy categories. The universe is allowed to be strange, and we're allowed to be wrong. What matters isn't whether we're right at this exact moment. What matters is whether we're willing to update our understanding when new evidence arrives. Whether we can hold our beliefs lightly enough that when better data appears, we can let go of what we thought we knew and embrace what actually is. Jupiter is teaching us this lesson in the most visceral way possible. It's showing us that even our most confident declarations, Jupiter is a gas giant, can be fundamentally mistaken. Not because we were stupid or careless, but because we were limited. Limited by technology, by observation, by the simple fact that we're finite beings trying to understand an infinite universe. And instead of being discouraged by this, I find it strangely comforting. Because if Jupiter can be this complex, this layered, this impossible to fully explain despite centuries of study, then so can you. You don't need to have yourself figured out. You don't need to fit into clean categories. You don't need to explain your core or justify your layers or make sense to people who are only looking at your surface. Jupiter has a diffuse core, and it's been orbiting the Sun for billions of years without needing anyone's permission or understanding. It exists in all its strange, metallic, liquid glory, indifferent to our confusion. You're allowed to do the same. Let me tell you what I mean by that. We spend so much of our lives trying to solidify, trying to become coherent, consistent, easily explained. We want a narrative that makes sense. I'm this type of person. I value these things. I'm moving in this direction. We want our core to be compact, well-defined, graspable. And when we find contradictions, when we discover parts of ourselves that don't fit the story, that seem inconsistent with who we thought we were, we panic. We think something's wrong. We think we're broken, or confused, or failing at the basic task of being a comprehensible human. But Jupiter suggests a different possibility. What if you're not broken? What if you're just diffuse? What if the contradictions aren't errors, but evidence of complexity? What if your core, your sense of self, your values, your identity doesn't need to be a compact sphere? What if it's allowed to be spread out, blended? A region where solid and liquid intermingle, where you can be multiple things at once without resolving into a single, simple truth. Think about the parts of yourself that feel contradictory. Maybe you're an introvert who craves connection. Maybe you're ambitious but also deeply tired. Maybe you love your life and also want to burn it down and start over. Maybe you're confident in some areas and utterly lost in others. These aren't bugs. They're not signs that you haven't figured yourself out yet. They're just layers. Different states of being existing under different pressures, at different depths, responding to different forces. Jupiter contains gas and liquid and metal, all at the same time, all as part of the same object. It's not confused about what it is. It's just large enough to contain multitudes. So are you. And here's the other thing Jupiter teaches us. Depth matters more than surface. We've spent 400 years photographing Jupiter's clouds. They're beautiful. They're iconic. The Great Red Spot alone has inspired countless images, paintings, documentaries. It's the face of Jupiter, the thing everyone recognizes. But those clouds are 50 kilometers deep. On a planet with a radius of 70,000 kilometers, that's nothing. It's 0.07% of the radius. It's wallpaper. The real planet, the ocean of liquid hydrogen, the metallic layers, the diffuse core, all of that is beneath the surface. Invisible, inaccessible. Operating according to physics, we're only beginning to understand, and yet we focused on the clouds for centuries. Because they were visible, because they were beautiful, because they were easier to study than the invisible, inaccessible truth beneath. How much of your own life are you experiencing as clouds? How much time do you spend on the surface level stuff, the visible markers of success, the performative aspects of identity, the things other people can see and photograph and judge, your job title, your social media presence, your productivity, your accomplishments? These aren't unimportant. Clouds aren't irrelevant just because they're thin. The Great Red Spot is real. It matters. It's part of what makes Jupiter remarkable. But it's not the planet. It's not the substance. It's not where the real action is happening. The real action in Jupiter and in you is deep. It's in the ocean of thoughts you never voice. It's in the metallic core of values that conduct your decisions even when you're not consciously aware of them. It's in the diffuse region, where your solid convictions blend with liquid uncertainty, where what you know mixes with what you're still figuring out. That's where transformation happens. That's where pressure creates new states of being. That's where hydrogen becomes metal. And you can't photograph it. You can't show it to other people. You can't even fully articulate it to yourself sometimes. But it's there, and it's more you than the clouds will ever be. So what do you do with this knowledge? How do you actually apply the lessons of a liquid metal planet to your own life, here now, on this small blue world? Let me offer some practices. Not prescriptions, not demands, but invitations. Ways of being that honor the Jupiter-like strangeness of your own interior. First, go one layer deeper than you're comfortable with. Pick one area of your life where you've been living on the surface. Maybe it's a relationship where you show up with smiles and pleasantries, but never actually share what you're struggling with. Maybe it's your work, where you execute tasks competently, but haven't stopped to ask whether this is what you actually want to be doing. Maybe it's your relationship with yourself, where you know your habits and preferences, but haven't examined the deeper currents that drive them. This week, descend. Just one layer. You don't have to go all the way to the metallic core, just past the clouds. In a relationship, share one true thing you've been avoiding saying, not to create drama, but to practice depth. I've been feeling distant lately, and I don't know why. I'm scared of disappointing you. I need help, but I don't know how to ask for it. In your work, ask yourself not, am I good at this, but does this matter to me? Sit with the question. Don't rush to answer. Let yourself feel whatever discomfort arises when you go beneath competence to meaning. In your self-understanding, take 10 minutes and ask, what am I afraid of? Write it down. Not the surface fears, spiders, public speaking, whatever. The deep fears. Failure, insignificance, being unloved, being too much, being not enough. Going deeper isn't comfortable. The pressure increases, the temperature rises, but that's where you discover what you're actually made of. Second, let your core be diffuse. Stop demanding that you solidify into a single, coherent identity. Stop insisting that your values must be consistent, that your goals must align perfectly, that every part of you must make sense together. You're allowed to be multiple things. You're allowed to contain contradictions. You're allowed to be uncertain. Here's a practice. Write down your contradictions without trying to resolve them. I love my partner, And sometimes I wonder what my life would be like if I'd stayed single. I'm proud of what I've accomplished, and I feel like I've wasted my potential. I believe in being authentic, and I perform a version of myself in almost every interaction. Don't use but, use and, because but tries to erase one of the truths to make room for the other. And lets both exist. Jupiter's core is diffuse because something catastrophic happened, a collision, a merger, a violent event that shattered the original structure. Maybe your diffuse core is the same. Maybe you're not confused. Maybe you're just mid-transformation. Maybe the contradictions are evidence that you've survived impacts that would have destroyed a smaller, simpler person. Diffuse doesn't mean damaged. It means complex. Third, study what's hidden, not just what's visible. We spent centuries obsessing over Jupiter's clouds because they were accessible. Meanwhile, 99% of the planet went unstudied. What are you ignoring in your own life because it's not immediately visible? Maybe it's your health. You track weight or appearance, but ignore the invisible metrics: stress, sleep quality, emotional resilience. Maybe it's your relationships. You count interactions, time spent together, but you don't measure depth. You don't ask, do I feel safe here? Can I be myself? Am I growing? Maybe it's your work. You optimize productivity, but never examine whether you're building something meaningful or just staying busy. This week, investigate something hidden. Journal about your internal state for 10 minutes every morning. Track your energy levels throughout the day and notice what depletes you versus what restores you. Ask someone close to you, what do you think I'm avoiding? The metallic hydrogen ocean exists whether we study it or not. Ignoring it doesn't make it less real. It just makes us less informed. The same is true for the hidden layers of your life. Fourth, update your model when evidence arrives. For decades, we taught that Jupiter was a gas giant. Then Juno arrived, and we rewrote the textbooks. We didn't call it failure, we called it progress. What belief are you holding on to, despite evidence that it's incomplete or wrong? Maybe it's about yourself. I'm not creative. Evidence: you just solved a problem in a way no one else thought of. You improvised a meal from random ingredients. You made someone laugh with an unexpected joke. Maybe it's about someone else. They don't care about me. Evidence: they showed up when it mattered, even if they're bad at words. They remembered something important to you. They asked how you were doing and actually waited for an answer. Maybe it's about how the world works. Hard work always pays off. Evidence: you've worked hard at things that failed. You've seen people succeed through luck or timing or privilege with minimal effort. Allow yourself to say, I used to believe X, now I'm not sure. That sentence, that willingness to hold uncertainty, is more intellectually honest than clinging to outdated certainty. You're not abandoning your values, you're updating your understanding based on new data. That's not weakness, that's how knowledge actually works. Fifth, sit with strangeness without needing to fix it. Jupiter is weird. Its core shouldn't be diffuse. Its metallic hydrogen shouldn't exist. It doesn't fit our models. And it's been orbiting the sun for 4.5 billion years without needing our approval. Find something in your own life that feels inexplicably strange, and instead of trying to resolve it, just acknowledge it. Maybe it's grief that arrives at random moments, years after a loss. Maybe it's a pattern you keep repeating even though you consciously choose differently. Maybe it's the gap between how successful you appear and how empty you sometimes feel. Don't analyze it. Don't Google, why do I feel this way? Don't therapize it into submission. Just say, this is strange. I don't understand it. And it's real. Your strangeness doesn't need to be solved to be valid. You don't need to explain yourself to exist. Sometimes the practice is simply allow the mystery to persist. Because here's the thing, and this is what I want you to carry with you when this video ends. When you close your screen and return to your life, you are not a simple object with a fixed composition. You are a gradient, gas to liquid to metal. surface to depth to core, clouds and oceans and metallic layers all existing simultaneously, all part of the same self. And just like Jupiter, your most important truths are buried deep. They operate under pressures invisible to others. They exist in states of being that don't fit clean categories, that can't be photographed or easily explained. You don't need to make sense. You just need to exist, fully, authentically, in all your strange, liquid, metallic glory. We are standing at the end of our descent now, having traveled from Jupiter's clouds to its diffuse core, from the great red spot to the metallic ocean, from certainty to mystery. And what have we learned? We've learned that the biggest planet in our solar system, visible, studied, photographed for centuries, was fundamentally misunderstood until less than a decade ago. We called it gas when it was liquid. We imagined a solid core when the core was spread across half the planet like soup. We were confident in our wrongness because we'd only ever seen the surface. We've learned that pressure creates transformation, that hydrogen, under enough compression, becomes metal. That what something is depends entirely on the forces acting upon it, the environment surrounding it, the depth at which it exists. We've learned that diffuse cores aren't failures, that Jupiter's blurred center, neither fully solid nor fully liquid, is evidence of a history too violent and complex to be captured in simple narratives, that sometimes things don't resolve cleanly, and that's okay. We've learned that depth matters more than visibility, that the clouds are beautiful, but they're not the planet. That 99% of what makes Jupiter remarkable is hidden beneath a surface we've been admiring for 400 years. And we've learned that the universe doesn't owe us simplicity. That reality is allowed to be strange, contradictory, impossible to fully explain. That our models will always be incomplete because we are finite beings trying to understand infinite complexity. But more than any of this, more than the science, more than the facts about liquid hydrogen and magnetic fields and diffuse cores, we've learned something about ourselves. We've learned that you don't need to be figured out, that your contradictions aren't errors, that your complexity isn't a problem to be solved, but a feature of being human, of being alive, of containing depths that can't be photographed or easily articulated. You are not broken. You've just been comparing yourself to a simple model, a clean, compact core surrounded by clearly defined layers, when you're actually built like Jupiter, diffuse, layered, full of metallic oceans and pressure-driven transformations and mysteries even you don't fully understand. And that's not a failure, that's what makes you magnificent. So here's what I want you to remember, what I want you to carry forward when you close this video and return to your beautiful, complicated life. You are not a gas giant pretending to be simple. You are a liquid metal world, deep and strange and full of invisible oceans. The pressure you feel, the forces squeezing you, transforming you, pushing you into states you don't recognize, that's not destroying you, that's creating new possibilities. That's turning hydrogen into metal. Your core doesn't need to be solid. It's allowed to be diffuse, spread out, a blending of solid convictions and liquid uncertainties. You're allowed to be mid-transformation, still figuring it out, carrying the evidence of collisions that would have shattered simpler people. And the parts of you that are visible, the clouds, the storms, the surface level performance, they're real, they matter, but they're not the whole story. Most of who you are operates beneath observation, in the dark, under pressure, generating the magnetic fields that actually shape your life. You don't need anyone's permission to be complex. You don't need to explain your diffuse core to people who are only equipped to study surfaces. You just need to exist, fully, honestly, in all your Jupiter-like strangeness, because somewhere out there, 780 million kilometers away, the largest planet in our solar system is spinning in the dark. It's full of metallic oceans and lightning storms and a core that doesn't make sense according to our best models. It's been there for 4.5 billion years, utterly indifferent to our confusion, magnificent in its refusal to be simple. It doesn't need our comprehension to be real. Neither do you. If this resonated with you, if you felt the weight of Jupiter's mysteries and recognized something of yourself in that frozen, churning giant, then I hope you'll stay with me for the next exploration. There are more worlds out there, more strange truths hiding beneath beautiful surfaces, more lessons written in planetary science that somehow illuminate what it means to be human. Leave a comment below and tell me, what surprised you most about Jupiter? Or, if you want to go deeper, and I hope you do, tell me about your diffuse core. What part of yourself refuses to solidify into neat explanations? What contradictions are you carrying? What metallic ocean is churning beneath your surface? Hit the like button if this spoke to something true in you. If you appreciate long-form exploration that treats you like an intelligent, emotionally complex person capable of holding nuance and strangeness, subscribe if you want more journeys like this into cosmic mysteries that reveal human truths, into science that becomes philosophy, into the spaces where knowing and not knowing meet. And remember, always, you are allowed to be as strange and inexplicable as Jupiter. You are allowed to contain metallic oceans and diffuse cores and storms that rage for centuries. Complexity isn't a flaw. It's the signature of reality itself. Thank you for descending with me into Jupiter's depths. Thank you for your willingness to explore not just the planet, but what it reveals about being alive in this strange, beautiful, liquid universe. Until next time, keep looking up, keep going deeper, keep honoring the metallic ocean inside you, and never, ever apologize for being too complex to easily explain.